Okay, so in this video, we are going to talk about the chapter Chemical Reaction and its types. We are going to start this chapter from changes. There are different kind of changes that happen in our everyday life. Like, let's say we have a beaker and we keep some ice here. And if we leave this for some time, then this ice is going to change into water, right? And again, if you heat this water, like let's say this is a candle, then this water is now going to change into vapor, right? So this is one of the changes that we can normally see. Another change that we can see is, let's say we have a piece of iron, and if we leave it in the atmosphere for some time, then we are going to see some red or brown powder on the surface of iron, which is rust. And this is also one of the changes that I think we can see in our life every day. And there are lots of changes that will happen in our everyday life, right? So, but for now, to understand chemical reaction and changes, we are just going to look at these two examples. This first example is an example of physical change, whereas the second example is the example of chemical change. The physical change is there's just change in state of these things, whereas in chemical change, the rust is being formed, so something is changing chemically in this change. Now we are going to look at what are the differences between these physical and chemical changes. Physical and chemical change. The physical changes that we just talked about, like the change of ice into water or the water into steam, they are temporary in nature, because you can change the ice back, like the water back to ice or the steam back to water, right? So they are temporary changes, whereas the chemical changes are permanent. So once you change this iron into rust, now it cannot be turned back. So since the physical changes are temporary, they are reversible. They can be reversed back. Whereas the chemical changes are permanent, so they are irreversible. There are chemical changes which are reversible as well, but like it's a little bit difficult. We need to meet certain conditions for that. That's why normally we are just going to say chemical changes are irreversible. And another difference that we can notice in a physical and chemical change is physical change. In case of physical change, no new substances are formed. Ice is still water. Liquid water is also water, and our steam is also water, so no new substances are formed. Whereas in chemical changes, new substances are formed, like rust is being formed. Right? Now, since our lesson is about chemical reaction, we are going to focus more on chemical changes than the physical changes. So like I said, the change of this piece of iron into rust, or like we see some rust on the surface of this like iron, and this is a chemical change. Now, how is this happening? How is iron changing into rust, or how is these rust are being formed? Like, how is it happening? And that process about how these chemical changes are occurring are called chemical reaction. Chemical reaction is just the process of chemical change, the process that's going on when this piece of iron is changing into like rust. What's the process? How is it changing? And that process is our chemical reaction. So what's happening here is we have iron, right? And we have oxygen in the atmosphere, and in the presence of moisture or water, what's going to be formed here is Fe2O3, and this is our rust. and that's how the change is happening, which is our chemical reaction. Now, chemical reaction can be represented in two ways. One of the ways is like word equation, and another way is chemical equation. So now we're going to talk a little bit about these equations, okay? So we talked about chemical reaction, and like I said, like it can be represented in two ways. One is word equation and the next one is chemical equation. So first let's look at word equation. Hydrogen and oxygen react with each other to form water. Now this is a chemical change, this is a chemical reaction, and we are representing this chemical reaction by writing the full names of the substances like hydrogen and oxygen and water. And if you write the full names of the substances involved in the chemical reaction, then it is known as word equation. And here the substances that are reacting with each other like hydrogen and oxygen are also known as reactants, since they are reacting with each other. And the substance which is formed after the reaction are also known as products. This is our product of the reaction. So if you represent a chemical reaction by writing the full names of the reactants and the products, then that equation is called word equation. For chemical equation, in chemical equation, what we are going to do is we are going to write the same chemical reaction, but we are not going to write the full names of these reactants and product. We are just going to write the molecular formulas of the reactants and product. Like hydrogen is S2, oxygen is O2, gives us water H2O. So if you write the molecular formulas of the reactants and products to represent a chemical reaction, then that is known as our chemical equation. Another chemical equation could be nitrogen reacts with hydrogen to form ammonia. So this is another chemical equation. So instead of molecular formula, if we write the full names like nitrogen and hydrogen combine with each other to form ammonia, then this is our again word equation. Okay. Now we have learned about chemical equations. So these chemical equations can be sometimes balanced and sometimes they can be unbalanced. So what does it mean by the chemical equations are balanced and unbalanced? So let's say we have carbon. Carbon reacts with oxygen to give carbon dioxide. So balanced and unbalanced chemical equation just means that the number of atoms in this reactant side and the number of atoms in this product side must be equal. So we have one carbon in the reactant and two oxygen, and in the product side also we have one carbon and two oxygen. So since the number of atoms in the reactants and product sides are equal, then this type of chemical equation are known as balanced chemical equations. Whereas if you look at this chemical equation, so there are two hydrogen atoms here, okay, that's good. But in case of oxygen, there are two oxygens, but there is only one oxygen here. So this chemical equation is not balanced, and these type of chemical equations are known as unbalanced, or they are also called skeletal chemical equations. Now we are going to learn how to balance these skeletal chemical equations or unbalanced chemical equations. So it's pretty simple. There are just some rules, and you just need to make the atoms on both sides equal, and that's done. So one of the rules is that you can't add numbers below the atoms just like that. Oh, I'll just make 2 here. You can't do that, okay? Next rule is you can't write numbers in the middle of the compounds, like I'll just write S2 and 2O, okay? This is also not right. You can't do that. What you can do is you can only add numbers in front of the compounds and molecules, okay? So you can add numbers in front, and you need to make the number of atoms equal on both sides. So how can you do that? So let's add some numbers. So we have 2 hydrogen and 2 hydrogen here, so that's not a big problem. In case of oxygen, so there are 2 oxygen here, but there is only 1 oxygen here, right? So if you write 2 here, now the oxygen is going to be 2 oxygens. But the hydrogen is now 4 in number, so 2 times 2 is 4. To make this hydrogen also 4, we just add 2. And now the number of hydrogen atoms is 4. The number of oxygen atoms is 2 in the reactant side. Similarly, in the product side, the number of hydrogen atom is 2 and the oxygen atom is also 2. You need to remember this thing, like you can't do this, okay? You can't add numbers in below the like atoms, and you can't like write numbers in the middle, okay? These two things you can't do. You can add numbers in front, and you just need to make the number of atoms equal. Now, okay, let's do some more examples, like just to make it clear, okay? So this is one of the reactions. Let's look at now another chemical equation. Nitrogen and hydrogen react with ammonia. So there are 2 nitrogen here, so there's only 1 nitrogen here. You just write 2, and the number of nitrogen are equal now, but the number of hydrogen is 2 times 3 is 6. There's only 2 hydrogen here. If you write 3 here, the number of hydrogen is going to be 6, and it's balanced. That's it. Okay, another one. Let's look at another one. Zinc plus hydrochloric acid gives us zinc chloride and hydrogen. So zinc is balanced. 1 zinc, 1 zinc. There are 2 chlorine. Just write 2 here. Now there are 2 chlorine. There are 2 hydrogens and 2 hydrogens. And then this is all again balanced. Whenever you balance chemical equations, like you balance hydrogen at the end, okay? So hydrogen and oxygen, you just balance them at the end. It will be a little bit easy to do it that way. Okay, let's look at another one. KClO3 gives us KCl plus O2. So KCl and KCl are balanced. There are 1 potassium, 1 potassium, 1 chlorine, 1 chlorine. Oxygen, there are 3 oxygen here. There are only 2 oxygen here. So whenever there is odd number, you just write 2 in front. So now there are 6 oxygen here. To make this oxygen 6, you need to write 3. But the potassium and chlorine are now 2 in number. So you just write 2 here. And again, it is balanced. And that's it. That's how you just add some numbers in front of these compounds and molecules, and then make the atoms equal in number, and you get your balanced chemical equations. So we started with changes. There are 2 types of changes, physical and chemical changes. Physical changes are temporary, reversible, and no new substances are formed. Chemical changes are permanent, they are irreversible, and new substances like rust is being formed. The process of this chemical change is known as chemical reaction. And the chemical reaction can be represented in 2 ways. One is by word equation, another is by chemical equation, right? If you write the full names of the reactants and the products, then that type of equation is our word equation. And if you write just molecular formulas, then it is chemical equation. And the chemical equations can be either balanced or they can be unbalanced. If they are balanced, you just leave it, you don't need to do anything. If they are unbalanced, then you need to add numbers. You can't add numbers below or in the middle. You can add the numbers just in front of the molecules. And you add numbers in front of the molecules and make the number of atoms in both the reactants and product sides equal, and finally you get your balanced chemical equations. So till now we have talked up to here. So this is all about chemical reaction. Now we are going to talk about the different types of chemical reaction. Types of chemical reaction. So we are going to talk about 5 types of chemical reaction in this video, and they are combination reaction, decomposition reaction, the third one is displacement reaction, acid-base reaction, and finally oxidation-reduction reaction. Okay, so let's start with combination reaction. So it's pretty simple. Like the name suggests, combination reaction is the reaction in which two substances combine to form a product. Like let's say we have A plus B, and A and B combine to form AB, then that is our combination reaction. Since the product is being formed like from A and B, something is being formed or synthesized. It is also known as synthesis reaction. Now let's look at some of the examples. Let's say hydrogen and oxygen react with each other to form water. So water is being synthesized here. And in this reaction, hydrogen and oxygen are combining, so it is also known as combination as well as synthesis reaction. Another example could be nitrogen and hydrogen combine to form ammonia. So this is another example of combination reaction. Okay, the next one is decomposition reaction. Decomposition reaction is the exact opposite of combination reaction. So in decomposition reaction, one compound breaks down into different products. For example, let's say we have AB, and this AB breaks down into A plus B, or decomposes into A plus B, hence it is called decomposition reaction. Some of the examples of decomposition reaction are like calcium carbonate. When you heat calcium carbonate, it breaks down into calcium oxide and carbon dioxide, so it's being decomposed into two products. Or like potassium chloride, again, when you heat this, it's going to decompose into potassium chloride and oxygen, and that's our decomposition reaction. Now the third one is our displacement reaction, and this displacement reaction is actually of two types. So let's see some examples. Let's say we have A plus BC react with each other to form AC and B. Here what is happening is this A is displacing B in this compound, and we have AC and the B is separate alone. So this is one of the displacement reaction. Another displacement reaction is, let's say we have AB plus CD, and if this A and C change their positions, then we will have AD and plus CB. So in the first one, A is replacing B and B is alone here. In the second one, the A and C are interchanging their places to form two different compounds. So here the cations and anions are being interchanged, whereas in the first one, the A is just replacing B, but B is not replacing anything in this first part. So this first type of chemical reaction is known as single displacement reaction, and then the second type is known as double displacement reaction. Okay, so now let's write some of the examples of single displacement reaction. For example, zinc reacts with hydrochloric acid to form zinc chloride and hydrogen. So this hydrogen is alone here. Next example could be iron reacts with copper sulfate to form iron sulfate and copper. So in both of these reactions, zinc is replacing hydrogen and iron is replacing copper, and this hydrogen and copper are single here. So this is our single displacement reaction. Some of the examples of double displacement reaction are, so silver nitrate (ZnO3) plus sodium chloride react to form silver chloride and sodium nitrate. So here the anions and cations and anions are interchanging their places to form new compounds. Another example could be sodium sulfate reacts with barium chloride to form barium sulfate and sodium chloride. So in these reactions, the cations and anions are interchanging their places to form new products. And this type of chemical reaction are known as double displacement reaction. So this Ag is going to be connected with this chlorine, and this sodium is going to be connected with this nitrate, and we have sodium nitrate and silver chloride. Similarly here, our sodium is going to be connected with chlorine, and then sodium connects with chlorine, and we have sodium chloride, and the remaining barium and sulfates are going to be connected to form barium sulfate. So this is our double displacement reaction. Now the fourth type of reaction is our acid-base reaction, and this is a pretty simple reaction. In acid-base reaction, acid and base reacts with each other or react with each other. So let's say we have an acid and this base, and this acid reacts with base to form salt and water. So if acid and base react with each other and it will form salt and water, then that type of reaction is acid-base reaction. Let's look at some examples again. Let's say we have an acid, let's say hydrochloric acid reacts with base sodium hydroxide. Then we will have sodium chloride, which is our salt, and water. So here acid and base are reacting with each other to form salt and water, and this type of reaction is known as acid-base reaction. Similarly, another acid could be sulfuric acid, reacts with, again, let's say sodium hydroxide base to form sodium sulfate and water. Here both these salt and water are neutral in nature, and since this acid and base are reacting with each other to form neutral substances, this type of reaction is also known as neutralization reaction. Now our last type of reaction is our oxidation-reduction reaction, and it's pretty simple reaction as well. So let's look at an example here. Let's say we have copper oxide reacts with hydrogen to form copper and water. So here what is happening is this hydrogen gains oxygen to form water. So here we have gaining of oxygen, and in this case the copper oxide loses oxygen to form copper. So we have losing oxygen here. So whenever there is gain of oxygen, then it is known as oxidation, and whenever there is losing of oxygen, then it is known as reduction. And this type of reaction is oxidation-reduction reaction. Let's look at one more example. So zinc oxide reacts with carbon to form zinc and carbon monoxide. So here this zinc oxide is being reduced to zinc, so we have reduction here again, and the carbon is being oxidized to carbon monoxide, so we have oxidation. And these type of reactions are known as oxidation-reduction reaction. So these are all the types of reaction. So what we learned is there are 5 types of chemical reaction: combination, decomposition, displacement, acid-base, and oxidation-reduction reaction. In combination reaction, 2 things combine to form a single product. In decomposition reaction, a single compound breaks down into different products. In displacement reaction, the positions of the elements are displaced from each other. So here A is replacing B, and here A is replacing C, and C is also replacing A. So there are 2 types of displacement: single and double displacement reaction. And then we have our acid-base reaction, in which acid and base react to form salt and water, which are both neutral in nature, hence they are also known as neutralization reaction. And finally we have our oxidation-reduction reaction, in which one of the reactants loses oxygen and the another one gains oxygen, which is known as oxidation and reduction, and the total chemical reaction is known to be oxidation-reduction reaction. And that's our 5 types of chemical reaction. I hope it was helpful. Thank you for watching till the end.